Okay, for our next example here, we're given a bunch of angles and we have to find the secants and cosecants of these common values. So let me start by drawing these angles on a unit circle. It's kind of a squished unit circle. Let me see if I can do a little better there. So this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. And it looks like at least one of these angles is given in degrees as well, so I'll label the values in degrees. There's 90, 180, 270, and 360. So those are the values in degrees. So let's figure out where these angles are in the unit circle. 5 pi over 6 is over here. 240 degrees is between 180 and 270. That's down here. And 7 pi over 4 is between 3 pi over 2 and 2 pi, so that's down there. So remember, secant and cosecant, those are just the reciprocals of cosine and sine. So the smart thing to do here is to figure out the cosine and sine of those angles, and then it'll be an easy matter to find the secant and cosecant. So I'm going to make a little chart. The angle, the cosine, the sine, and then it'll be an easy matter to find the secant and cosecant. So we'll start with 5 pi over 6. That's over here, and that's a 30, 60, 90 triangle, so we know the values. The cosine is root 3 over 2. Sine is 1/2, but then we have to worry about whether they're positive or negative. Well, the x-coordinate's negative there, so I make the cosine negative. The secant now is just 1 over cosine. So that's 2 over the square root of 3, but if we rationalize that, that's 2 root 3 over 3, and of course it's negative. And the cosecant is 1 over sine, so 1 over 1/2 is just 2. Now the next one is 240 degrees. 240 degrees. If you like to translate that into radians, that's 4 pi over 3. That's this angle down here. Again, we see a 30, 60, 90 triangle. This time the cosine is the short side, so that's 1/2. The sine is the long side, root 3 over 2. But it's in the third quadrant, so they're both negative. Now, the secant here is 1 over cosine, so that's negative 2. Cosecant, 1 over sine, 2 over root 3 rationalizes to 2 root 3 over 3, and that's negative. Finally, 7 pi over 4, that's this angle over here. Again, helps to start out with the cosine and sine. That's a 45-degree triangle, so we know they're both root 2 over 2. And then we just have to figure out which one's positive and which one's negative. Well, the y-coordinate is negative there, so the sine must be negative. Okay, the secant is 1 over the cosine, so 2 over root 2 is just root 2. Cosecant, 1 over sine, is 2 over root 2, so that's root 2 again, but it's negative. So we get that. So I really emphasize to my students that you don't really need to memorize the secant and the cosecant of the common values if you really have the sine and cosine memorized well. So I think it's more important to memorize the sine and cosine very well, and the way you get those is by knowing those common values for the 30, 60, 90 triangles and for the 45, 45, 90 triangles. You use those to figure out the sines and cosines. You figure out which quadrant you're in, which tells you whether they're positive or negative. So now you know sine and cosine and whether they're positive or negative. And then for secant and cosecant, you really just, all you have to remember is that secant theta is 1 over cosine theta. If you can figure out the cosine, you can figure out the secant. Similarly, for the cosecant of theta is 1 over the sine of theta. Again, if you figure out the sine of theta, it's a simple matter to figure out the cosecant of theta. So I hope those all worked out well for you. This is part of the trigonometry lecture series for educator.com.